So I've learned what I know about education and how we learn to some extent from my own research. And of course, as Rebecca mentioned, my research includes things like neurobiology. And in that research, I have studied things such as how neurons communicate with each other, how the brain stores memories, how the brain encodes social behavior. So that's why we created this program that we began in 2017. I'm going to show you a certain amount of our experiences from the 2018 program. The 2018 program was held on the Harvard campus, and the research was actually done in the Harvard Biolabs building where I'm now sitting. And these are the students. We had 12 students that second year of the program. And we called it that year, we called it the Crimson Bioacademy. Next slide. So the main philosophy of this program and what we thought would allow these students to go along this path that I've described is, first of all, to give them cutting edge research projects, not to have them do something that we would call a training exercise, like learn how to use a simple piece of apparatus, learn how to pipette, learn how to weigh something, to just do something that's a technique. We didn't want them to just learn techniques. We wanted them to get excited about research. And in that case, we thought, well, gee, if the students are going to get excited about research, we should bring projects that are exciting enough to actually be worked on in the research labs around us to their bench and have them work on these projects. And of course, knowing a lot of different labs and a lot of different projects that are going on, we put together a set of 3 projects. And so the students were divided up into groups, and this is important. I'll get to that in a second. We wanted students to learn to work together. So that's the purpose of having groups. But we didn't want, say, okay, one group to have the exciting project and another group to have the boring projects. We don't know how these things would turn out. So we had everyone do every project. Of course, that made more work. It was quite an intense experience for the students, but and it kept them quite busy. But they got to learn a lot more by doing several projects at the same time, which of course is how we do research anyway. We're not always just working on one thing. So what were the projects and why were they interesting? Well, one of the projects had to do with the question of, well, what is consciousness? How do we define consciousness? That's somewhat of a philosophical question, of course, but experimentally, we wanted to define consciousness. And so we thought of a way to do that. I'll talk about that in a second. We wanted to do something that's a little more down to earth, translational, we call it. So we were interested in bringing into the lab for the students a project that involved testing small molecules to act as drugs to interfere with the growth of cancer cells. And this relied on what they call high throughput chemical screening. So this is, of course, done very often nowadays. It's done in pharmaceutical companies, but we also do it in research labs. I won't talk about this, but it's also a very interesting type of project. And of course, as I mentioned, we wanted to bring in very high technology approaches to the research of the high school students. And so we had them use something called massively parallel RNA sequencing, which is, of course, nowadays is the kind of technology that people use to be able to sequence a patient's DNA genome in a day. And of course, that's possible to do. We can nowadays, a person who is a patient, say a cancer patient, we could take DNA from their tumor and scan that DNA for mutations that are causing their cancer, have a result within a day and devise a treatment on the basis of that. Now, in the context here, it's more a basic research question, and that was to identify genes that may be causing Alzheimer's disease. And I think, many of you may have heard that there have been recent FDA-approved treatments for Alzheimer's disease. We actually are questioning, and of course there are questions about those treatments and how effective they are. We're questioning the rationale in this project and looking for alternative treatments. So as you can see, this is really a lot of research for which the answers are not known or were not known, in which the students were given the opportunity to make progress. And I think that's very exciting for a young budding scientist, is to see that, that they might actually be discovering something. And our job as teachers was to facilitate their ability to discover and experience that excitement. Next slide. So in order to conduct this kind of high technology research, as I said we were doing, is we made use of core facilities. And this is something that we have. Many universities have this because nowadays high-tech equipment is very expensive. Individual laboratories really cannot afford to buy all of the machines themselves. And so we create a facility where there are all these machines. And you're looking at, on the screen on the left and on the right, you're looking at millions of dollars worth of scientific equipment.